Out of all the planets in our solar system, Venus stands out in a way that is both mesmerizing and terrifying. Often called Earth's sister planet because of its similar size, mass, and proximity to the Sun, Venus has long been a subject of intrigue. But the deeper we look into the mysteries of this golden orb, the more we uncover a world that seems, at first glance, utterly inhospitable. A place of extremes, a world unlike Earth in every conceivable way. So, we must ask ourselves, could humanity ever live on Venus? Could we, one day, find a way to thrive on a planet with a surface hotter than an oven and an atmosphere so dense it could crush any unprotected being? Let's take a closer look at what Venus is really like, what it would take to survive there, and how far we might be from making a floating city in the clouds of Venus a reality. Venus's most immediate and overwhelming feature is its atmosphere, one of the most hostile environments in the entire solar system. The dense cloud cover is composed of clouds of sulfuric acid, making the air toxic and corrosive. These clouds create a thick, almost impenetrable veil, preventing us from seeing the surface with our naked eye. The pressure at the surface of Venus is 90 times greater than Earth's, equivalent to the crushing pressure found 3,000 feet beneath Earth's oceans. In fact, the weight of the atmosphere alone is enough to crush an unprotected spacecraft or any human habitat built on the surface. But there's more. Venus's surface temperature is so high. It's a world where the heat is so intense it could melt lead. At 900 degrees Fahrenheit, 475 degrees Celsius, the planet is hotter than Mercury despite being farther from the Sun. This is the result of an extreme greenhouse effect, where Venus's thick atmosphere traps heat and raises temperatures to unbearable levels. But even these facts don't fully convey the scale of the challenge we'd face if we were to consider colonizing Venus. The heat, pressure, and toxicity alone make the planet's surface a literal hellscape. But there's a silver lining: Venus's upper atmosphere. If we venture upwards, far above the searing surface, we find that conditions improve considerably. At altitudes around 30 miles, 50 kilometers, above the surface, the temperature is much more temperate, hovering around 75 degrees Fahrenheit, 24 degrees Celsius, akin to a mild day on Earth. The pressure here is also comparable to Earth's, similar to the pressure you'd experience at sea level. This altitude represents a habitable zone, where temperatures and pressures are within the range that humans could, in theory, endure. The challenge, then, becomes finding a way to live in this narrow region of Venus's atmosphere, suspended high above a world that could destroy us in an instant. Enter the concept of floating cities. If humanity is to survive on Venus, it would almost certainly have to take refuge in the upper atmosphere, far above the uninhabitable surface. The idea of floating cities, vast, self-sustaining habitats suspended by massive balloons or airships, has been proposed as a possible solution. These cities would be suspended at the habitable zone, where the temperature and pressure allow life to thrive. The concept of buoyancy in the dense atmosphere of Venus is key. Just as hot air balloons float on Earth by using buoyant gases to offset gravity, massive airships would use the thick carbon dioxide-rich atmosphere to stay aloft. These structures would need to be designed to withstand the powerful winds, which can reach up to 200 miles per hour, and the corrosive sulfuric acid clouds. Inside these floating habitats, life would need to be carefully managed. The most immediate concern is air quality. The atmosphere of Venus is made up of nearly 96% carbon dioxide, which is completely unbreathable for humans. Thus, large-scale air filtration systems would need to be installed, capable of removing carbon dioxide and producing oxygen for the inhabitants. In fact, just as our current space stations rely on technology to maintain life support systems, so too would these floating cities need to rely on renewable energy sources, primarily solar power. Because Venus receives an enormous amount of solar energy, the upper atmosphere would be an ideal location to deploy massive solar panels capable of harnessing this energy. These solar arrays would need to be much larger than anything on Earth, capable of powering the life support, filtration systems, and essential operations of the city. And then, there's the issue of food. To survive in the clouds of Venus, humans would need to produce their own food. One solution might be hydroponic farms, where crops are grown without soil, using mineral-rich water solutions. The controlled environment within the floating cities could allow for year-round cultivation of food, supporting a population in this isolated environment. Venus's winds are another challenge that would need to be overcome. At the surface, winds can reach speeds of 200 miles per hour, faster than the most powerful hurricanes on Earth. At higher altitudes, while the winds are somewhat calmer, they still pose a significant threat to floating structures. To keep these cities stable in the turbulent skies, advanced stabilizing technologies would need to be developed. One possibility could be large tethering systems, which anchor the floating cities to massive platforms that float with them in the upper atmosphere. These platforms would need to be designed to absorb and counteract the powerful forces of the wind, preventing the city from being knocked off course or destroyed by the relentless gusts. But surviving on Venus wouldn't be limited to managing the environment inside the cities. The radiation from the sun would also pose a serious threat. Unlike Earth, Venus lacks a protective magnetic field that shields us from harmful solar and cosmic radiation. Without such a magnetic field, the upper atmosphere is exposed to unfiltered radiation, which could be deadly in large doses. To protect the inhabitants of these floating cities, radiation shielding technologies would need to be put in place. This could include the development of thick, durable materials, perhaps new alloys or composites, designed to absorb or deflect harmful radiation, preventing the city's inhabitants from being exposed to dangerous levels of solar radiation. Could we one day build these floating cities in the clouds of Venus? It's not a question of if, but when. With advancements in aerospace engineering, solar power, life support systems, and material sciences, the dream of Venusian colonization might be closer than we think. The next few decades could see the development of technology capable of surviving in such an extreme environment. The data from upcoming missions like NASA's Veritas and ESA's Envision will provide vital insight into Venus's geological history and perhaps unlock secrets that could help us understand how to survive there. The first human colonies might not be on the surface of Venus, but rather suspended among its clouds, living in a delicate balance between humanity's ingenuity and the fierce forces of nature. It's a vision that once seemed far beyond our reach, but as we continue to expand our technological capabilities, perhaps one day, the clouds of Venus could become the cradle of a new civilization.